Hello, my name is Alex Rogado, and this is my video project for Math 12, Spring Semester, Discussion Section 23. Today I will be discussing the mathematics in music, covering theory, counting, and pitches. We'll begin our discussion today with counting. Counting may seem overly simple when it comes to mathematics and music, but it is absolutely critical and can be more difficult as the music increases in difficulty. When reading music, it is important to note that every type of note you see has a certain value. This value determines how long a note is held for. For example, this black note with a tail is known as a quarter note and has one beat in value. Because it is a quarter note, 4 quarter notes take up one measure of 4/4 time. So this measure here will be counted as 1, 2, 3, 4. Applying that same logic, this white note here is known as a half note. One half note is held for 2 beats, with 2 half notes taking up one measure of 4/4 time. This measure here would be counted as 1, 2, 3, 4, with each individual half note accounting for 2 beats. And finally, we have this whole note. As you can likely guess, a whole note is held for 4 beats, with one whole note taking up an entire 4/4 measure. So this measure would just be held for 4 consecutive beats. So 1, 2, 3, 4. And when I say 4/4, what does that mean? 4/4 time refers to the time signature, which can be found here at the beginning of each set of music. The time signature tells us how many beats are in one measure, as well as which note is emphasized in the beat. In 4/4 time, there are a total of 4 beats in a measure, with the quarter note being emphasized. So 1, 2, 3, 4. Similarly, in 3/4 time, there are 3 beats in the measure. And with the bottom number being 4, that means the quarter note gets the beat. So 1, 2, 3 quarter notes. Getting into the sound aspect of music, these symbols indicate how the pitch or frequency of a note is changed. If a note has no sign or has this sign, the note is natural and its pitch is unchanged. For example, if I have the note C, this is C natural. This is what C natural would sound like in its unchanged, unaltered pitch or frequency. Now, if I raise the note 1/2 step to a C sharp, indicated by this symbol, it doubles the frequency. So if I go from C natural, which sounds like C sharp, would sound like this. Now, if I lower the note's value 1/2 step from its natural state, it's indicated by this symbol, flat, and therefore lowers the note's pitch 1/2 step from its natural state, effectively halving the frequency. So if I have C natural, which sounds like this, and I want to change its frequency, lowering it 1/2 step, and halving the frequency, it would sound like this, C flat. Now, if all this talk of frequency sounds familiar, you may know a little bit about sine waves. By transforming sine waves, we can change the frequency or how often waves appear in a single period. For example, if we have sine of 2x and we take that to be our natural state, changing it from sine of 2x to sine of half x by multiplying it by 1/4 doubles the frequency, as you can see here, and turns it sharp, if we were comparing it as an analog to music. Now, multiplying sine by 1/2 changes it to sine of x and halves the frequency, giving us going from here to here. Now in music, that's equivalent to taking natural and turning it flat by halving the frequency. All of the sharps and flats in music can be found in the key signature. If we count how many flats or sharps there are and where they are, we can figure out what key the song is, based on the circle of fifths. If this looks familiar, you have likely taken a Math 5 course or other similar pre-calculus course, because this is very similar to the unit circle. Rather than find degrees, sines, and cosines, however, the circle of fifths tells us what key we're playing in. And another parallel, if you notice, the number of sharps increases as you go down this way. Similarly, the number of degrees decreases this way. A very, very interesting parallel between these two is if you take C major, no sharps, you take 90 degrees, sine of 90 is 0. Similarly, a C major has no sharps or flats. Another mathematical parallel bridging the worlds of trigonometry, calculus, and music. The unit circle, the circle of fifths. Thank you so much for watching. I hope you enjoyed my Math 12 video on mathematics in music, covering theory, pitch, and counting. Thank you so much. Have a great rest of your day.
For my video project, I cited Music 101, What is the Difference Between Sharp Notes and Flat Notes, by the Masterclass staff at masterclass.com. I've also cited Music Theory in 16 Minutes by G. Michelmore on YouTube, as well as the Music Theory article on Wikipedia.